I welcome all the students to AKI's Pune College of Arts, Science and Commerce, Camp Pune 1. Myself, I am Dr. M.B. Pathan. I teach Statistics Paper 1, Discrete Probability Distribution and Time Series. Yesterday, we have started a new chapter, Multinomial Distribution, and we have seen the introductory part of the multinomial distribution. I had given you the joint PMF of multinomial random variables. After giving the definition, I told real life situations where you can apply multinomial distribution. Also, we have seen certain remarks on multinomial distribution. Under multinomial distribution, we study k random variables with condition x1 plus x2 plus x3 dash dash plus xk equal to n. Particular random variable satisfies the properties of binomial distribution. Yesterday, we have seen how to develop the MGF of multinomial distribution by using MGF, how to derive mean of ith random variable, and we got the answer expected value of xi equal to n multiply pi, as well as we developed the derivation of variance of xi, and we got the answer variance of xi equal n multiply pi multiply qi. As per the remark, when you study only one variable under multinomial distribution, it satisfies all characteristics of binomial distribution. And that is why expected value of xi is npi, variance of xi is npi multiply qi. I had given you two questions which may be asked on the basis of yesterday's topic. Today we will proceed ahead. Let us see how to get covariance of I, jth random variable in multinomial distribution. That means we study two variables out of k variables, and for that two variable, what will be the covariance? Covariance is a statistical measure which gives the idea about variation in between. So here we have xi and xj as the two random variables coming from multinomial distribution. So it is quite natural to have a knowledge of covariance. So we'll try to develop covariance between xi and xj. According to your first year knowledge, you know covariance of xy is expected value of xy minus ex into ey. Same definition we are using here. In place of x, take xi. In place of y, take xj. So you will be having covariance of xi comma xj as expected value of xi multiply xj minus product of separate expectation. What is I and what is j? I not equal to j equal 1 to k. If I equal to j, what will be happen? Let us check. Suppose I take I, j both equal, and that equal to 1. So it will be covariance of x1 comma x1. So this is expected value of x1 multiply x1, that is x1 square, minus e of x1 multiply e of x1. So it is e of x1 bracket square. So it provides you variance of x1. And that is why when you develop the covariance, we put a condition I should not be equal to j. If I equal to j, it gives a variance of that variable. So from yesterday's lecture, we have the knowledge expected value of xi as npi, which we derived yesterday. expected value of xj is equal to npj. So to get a covariance, we require one thing to develop, that is expected value of xi into xj, where expected value of xi into xj is equal to differentiation of mgf with ti and with tj. After end of the differentiation, replace t vector as a 0. Then you will get the answer for expected value of xi into xj. See what is the expression. So d by dti, curly bracket, d by dtj. This is the MGF expression what we derived yesterday. Curly bracket complete. And at the end of two differentiation, t vector taken 0. So next line, d by dti. Now I differentiate this quantity with respect to tj. So what mathematics says, power is multiplied the entire function as it is and power reduced by 1 into differentiation of this bracket for your particular term tj. So you will get pj exponential differentiation always as it is, and differentiation of tj with tj is 1. So that is not written here. Now, after this, I go for second differentiation. Before that, here I want to differentiate with respect to I. So this n is a constant, pj is a constant, e to the power tj is also constant, because we are differentiating for ith term. So in respect to I, you get this as a constant terms. So we took it out. E to the power tj, n multiply pj. Now this bracket is differentiated with respect to I. So this n minus 1 become multiplied, complete bracket as it is, n minus 1 become n minus 2 into differentiation of this bracket with respect to I. So pi multiply e to the power ti. After ending the both differentiation, now throughout I replace t as a 0 everywhere. So e to the power 0 is 1. So you drop this term. N multiply pj, n minus 1. When I put everywhere t as a power 0, so this become 1, this become 1, this become 1. So you get P1 plus P2 plus dot dot plus Pk power n minus 2. Pi as it is, and e to the power t is 0, so this become 1. Hence, what I got? I got expected value of xi, xj, expectation of product of two variables, n into pj into n minus 1 into pi, because this bracket total is 1. 1 to the power anything is 1. So this term is cancelled. So this is the answer for expected value of xi into xj. Now we want to develop covariance. So covariance of xi, xj, by definition, expected value of xi, xj minus e of xi multiply e of xj. You have this answer, expectation of product, n multiply n minus 1 multiply pi, pj, that is here, minus e of xi is npi, e of xj is npj. Now let us simplify this. N multiply n become n square, multiply pi, pj, n multiply minus 1 multiply pi, pj, minus n into n is n square, pi into pj. So this is a negative term, this is a positive term, get cancelled. So finally what I got, covariance of xi xj is minus n time pi pj, I not equal to j, start from 1 to k. So I got covariance between two variables. Now in this expression, we have an important thing to understand. N represent number of trials, which never negative. Pi is a probability never negative. Pj is a probability for jth random variable. So these three quantities are positive. So what this minus sign says, it says that under multinomial distribution, if you study any two variable, they are oppositely related. That means xi is negatively correlated with xj, and vice versa, xj is negatively correlated with xi. More clearly, if xi value is increasing, xj will be decreasing. That is the opposite behavior between xi and xj. That is the interpretation from this negative sign. Let us put some remark on the calculation. In multinomial distribution, the random variable are negatively correlated. So this is the remark derived from this expression. If covariance is negative, the correlation is negative. And what is the definition of negative correlation? From your FY first year, the two characteristics, two variables are said to be negatively correlated if they behave oppositely. One increases, other decreases, and vice versa. So this minus sign says under multinomial distribution, xi and xj are negatively related. Any one of them is increasing, other is decreasing. Second remark, we write variance, covariance matrix for multinomial random variables. Under multinomial distribution, we have k variables, so you are able to write variance covariance matrix having k rows and k columns. Let us see how it looks. We have correlation xi xj minus root pi pj qi qj. This I will tell you after this discussion. Or before that, you can check easily what is a correlation from first year. It is a ratio of covariance divided by root of standard deviation. Covariance is minus n pi pj divide root of variance of xi, another root variance of xj. What is the variance of xi? Root, that is the standard deviation, root n pi qi. Another root n pj qj. So from denominator, root n and root n will be taken out. That become n, cancel with numerator n, and the remaining term is simplified like this. So this is the correlation formula derived by using a covariance and variance formulae. So this again says that correlation is a negative, and therefore variables under study for multinomial distributions are negatively correlated. Let us proceed ahead. Variance covariance matrix of NBD. Let X vector follows multinomial distribution with parameter n, comma p1, p2 dash dash pk. Then we have variance of xi equal to n time pi qi, I from 1 to k. Covariance of xi xj, here comma should be there, minus NPI QI, just we have developed. It should be QJ because it is XJ. B, remember, this is J. I not equal to J, 1 to K. So we write variance-covariance matrix denoted by capital sigma. First row stand for x1, second column for x2, and the last column for xk. Now inside the matrix, we have to write the corresponding expressions. Here, first element represent variance of x1. And we know variance is n time pi qi, so it is n time p1 q1. Now if I speak for this element, it is a study of x1 with x2. So when variables are not equal, it represents the covariance. So it is minus n p1 and this is p2. There is a mistake. This not qi, it should be pj. So when you will download the notes, you make a correction. This is not qi, it should be pj. pi for xi and pj for xj, and that's why here minus n p1 p2. Now for this element, what is the location? It is in front of x1 and below k. So this is the covariance of x1 with xk. So result is minus n p1 pk. Now if you look this element, it is located at second row and first column. So again this is not equal, so it is a covariance. Minus n second variable p2 and first variable p1. Now this is 2 and this is 2. That means it is a study of same variable. Same variable provide a variance. So you know the variance np2q2. This minus is not there. Dash dash, this is the element to study x2 with xk. So it is minus np2pk. Like this we do last row kth variable under first variable. So this is again covariance, and the last element, it is a study of kth variable with kth variable. That's why it is a variance. So this represent variance-covariance matrix of multinomial distribution. Now on this matrix, we can study some mathematical terminology that is called as a rank. Rank of variance-covariance matrix of NBD, of multinomial distribution. We decide rank of variance-covariance matrix in multinomial distribution by finding its determinant. What is the concept of rank in mathematics? Rank suggests how many vectors are orthogonal in your matrix. That is the concept of rank. Suppose you study matrix of 3 cross 3. That means it is the arrangement of 3 vectors. Now you want to check out of these 3 vectors, how many are orthogonal? And that is decided by calculating determinant of your matrix. If the determinant of given matrix is non-zero, then rank is a full order of the matrix. If determinant of matrix coming 0, then we conclude rank is less than order of the matrix. Now we'll try to see what is the rank of this matrix, variance-covariance matrix of multinomial distribution. We do mathematical operation on the matrix, on the determinant. We add all rows in last row we get. That means in this last row, we add the previous all the rows together. That means here np1q1 plus this and here. So if you add all these elements in the last, for every column, for every row, the final simplification comes like this. And we know in mathematics, when you try to find determinant, you can apply algebraic operations on rows and columns. By this, the determinant value does not change. So I make a algebraic operation on this matrix, add all rows in the last row. So we get this answer. Now if I try to find determinant of this by taking this as my evaluative row, so 0 multiply the remaining, 0 multiply by remaining determinant. So you easily get determinant of variance covariance matrix, that is 0. And so we have rank of covariance variance matrix less than k, because determinant of sigma for this is coming 0. And when determinant is 0, rank is less than the order of the matrix. So what will be the rank? Rank of variance covariance matrix is k minus 1, because if I take submatrix of order k minus 1, that matrix is not coming 0. And this I told in the remark of definition of multinomial distribution. There is a linear constraint x1 plus x2 plus dash dash xk equal to small n, and you can express any one random variable in terms of remaining k minus 1 random variables. So in the true sense, even though you are studying a k variables, out of k, k minus 1 are independent and 1 is depend on the k minus 1. And that is why you get rank of variance covariance matrix as k minus 1. This is very important to solve multiple choice questions. I put a question on this. Find variance covariance matrix for multinomial distribution with parameter 3, P1, P2, P3 is 1 by 3. Also find rank and interpret the result. So I took purposely this numerical example to understand previous two pages, how it is k minus 1 and how you get such type matrix in general. So we'll try to verify this matrix as well as the rank by using this numerical example. Now I have how many variables? I have 3 variables under study: x1 for p1, x2 for p2, x3 for p3. It is given that x vector follows multinomial distribution with parameter 3, comma, p1, p2, p3 equal to 1 by 3. What is your knowledge about variance of xi? It is n multiply pi qi, I from 1 to k. What is the covariance we developed today? It is minus n pi pj. I not equal to Z. I have only 3 variable under study. So I can write variance covariance matrix sigma with 3 rows and 3 columns. What is this first element? It is x1 with x1, so it is a variance. And variance for x1 is n times p1 q1. What is this element? It is first row, second column. So it is study of covariance. Minus n p1 and p2. J for column, I for row. So first row and second column. So answer is minus n p1 p2. I have third variable minus n p1 p3. Similarly here it is a second row and first column. So minus n p2 p1. Now this is the second row and second column. So it is study of one variable. And study of one variable is a variance n p2 q2. This is a covariance between x2 with x3. This is a covariance between x3 with x1. This is the covariance between x3 and x2. And this is the variance between x3 with x3. So n times p3 q3. Now this is your variance covariance matrix in general notation. Now your problem says P1, P2, P3 is 1 by 3. So if P1 is 1 by 3, Q1 will be 2 by 3 because it is 1 minus P1. So I put the values here. N is 3, P1 is 1 by 3, Q1 is 2 by 3. 3 get cancelled, result is 2 by 3. Same thing here, this 3 and this is 1 by 3, 1 by 3. So result is minus 1 by 3. Here also minus 1 by 3. Same calculations. So this is my variance covariance matrix for 3 variables. Now I want to decide what is the rank of this matrix. How I can decide? By calculating determinant. So to decide the rank, we perform row operations. Add all rows in first row. That means add this here, add this here. So what will be the result of this? Minus 1 by 3, minus 1 by 3 and plus 2 by 3. Result becomes 0. Add this in first. So minus 1 by 3 plus 2 by 3 is 1 by 3 and 1 by 3 with minus 1 by 3 is 0. Add this and here. So result to become 0 that we have seen in general. Here I add in the last. You can add anywhere. So the same thing happening for 3 variable study. So after adding all the rows in first row, what you get? You get 0, 0, 0. Now you know how to find the determinant. Take 0 element, drop the corresponding row and column, the remaining of this determinant. But 0 multiply anything is 0. So minus time this, drop this, the remaining determinant, but this is 0, that's why everything is 0. So determinant of 3 by 3 becomes 0. That means it says rank of sigma should be less than 3. Original determinant is 0 of order 3 cross 3. So determinant value 0 indicate corresponding matrix should have rank less than the order. How to decide? Take now 2 by 2 matrix of your sigma submatrix and then find the determinant. If it is non-zero, that is your rank. So now I take 2 by 3 minus 1 by 3 minus 1 by 3, 2 by 3 as a submatrix of this. You can take any submatrix of 2 by 2. So I took a submatrix and I got answer 2 by 3 multiply 2 by 3 minus this multiply this, that is the rule of determinant 2 by 2. Result is 3 by 9, which is not equal to 0. So it tells you rank of your variance covariance matrix of 3 variable is coming 2. So in general, if you have k variables, you can say how much rank? You can say rank is k minus 1, because in particular for 3 variable rank is 2. So for k variable rank is k minus 1. That is easily mathematically we proved.